Hypothesis at the beginning of this experiment was that the milk with the greatest amount of fat content would have the greatest amount of calcium, and we have proven our hypothesis because we see that whole milk is 3.25% milk fat, right? And you see that out of all of these samples, this has the greatest amount of precipitate. And the way it works is essentially the calcium in the milk, the greater amount of calcium in the milk would react with the excess phosphoric acid that is present in the Coke, therefore creating precipitate. Therefore we can measure that the one with the greatest precipitate would have the greatest amount of calcium. And as predicted, the 2% milk has the second largest amount of calcium phosphate, and then the 1% is after. And the non-fat milk we see is still like, it doesn't really have a lot of precipitate, and we can see that therefore non-fat milk has a very low amount of calcium since there's not a lot of precipitate, and it still hasn't even begun to like settle. So, and we just had this awkward chocolate milk sample, so we were just trying to test all of these out to see, because the chocolate milk didn't really have a milk fat, so we were going to figure out where chocolate milk fit on this spectrum. So we figured out that it would fit between the 1% and 2% fat milk, and because it has the calcium content and precipitate in between those levels.
So in conclusion, here's our final data. The mass of the calcium phosphate was determined by subtracting the mass of the filter paper from the mass of the filter paper and the precipitate. We decided to disregard the mold formed over the 3 days we let it dry, since the mass was very negligible. So overall, the mass of the calcium phosphate for non-fat milk was 15.04 grams, 1% was 17.53 grams, 2% was 21.13 grams, and whole milk, or 3.25% milk fat, had the largest amount of 23.49 grams. Chocolate milk had a mass of 21.70 grams of precipitate, and so, since it was most similar to the 2% milk fat precipitate amount, we can conclude that the chocolate milk had a similar percentage of milk fat to 2%. The overall trend of the data suggests, just like we hypothesized, that the more percent milk fat there is in the milk, the more calcium there is to react with the phosphoric acid in the Coca-Cola. And thus, the more percent milk fat there is in the milk, the more calcium phosphate it creates.